Hello everyone, let's look over chapter 6, state of the matter. There are three state of the matter: solid, liquid, and gases. All three state of the matter have the certain properties, have distinguished between the state. For example, density, shape, compressibility, and thermal expansion. You can calculate density. Density equals mass over volume. Unit of density is gram per milliliter or gram per cubic centimeters. Let's create define relationship. 1 milliliter equals 1 cubic centimeters. Let's say remember define relationship. 1 milliliter equals 1 cubic centimeters. So when you look at kinetic molecular theory of the matter, postulate number one. Matter is made of tiny particles called molecules. Number two, particles of the matter are in constant motion and therefore possesses kinetic energy. Postulate three, particles possess potential energy as a result of the repelling or attracting each other. Postulate number four, average particle speed increases as temperature increases. Number five, particles transfer energy from one to another during collisions, in which no net energy is lost from the system. There are two types of energy: kinetic energy and potential energy. Kinetic energy is energy particle has as result of being in motion. You can calculate kinetic energy. 1 over half times mass times velocity squared. Potential energy is the energy a particle has as a result of the being attracted to or repelled by other particles. Okay, let's calculate kinetic energy of two particles with masses of 2.00 gram and 3.00 gram if they are both moving with velocity of the 15.0 centimeter per second. When you insert given number unit, kinetic energy of the 2.00 gram particle is 225 gram centimeter square over second square. Kinetic energy of 3.00 gram of particle is 373.5 gram centimeter square over second square. What does it mean? So the more massive particle has more kinetic energy. So when you focus on solid state, the state characterized by high density, definite shape, small compressibility, and very small thermal expansion. Liquid state characterized by high density, indefinite shape, small compressibility, small thermal expansion. What about gas? So low density, indefinite shape, large compressibility, moderate thermal expansion. Okay, let's solve problems. Which set of the matter has a definite volume but indefinite shape? That's a liquid. What about gas? Gas has indefinite, indefinite volume, indefinite shape. What about solid? definite volume, definite shape. We can calculate pressure. Pressure is calculated by force per unit area of a surface. Can use several units of the pressure, for example, atmosphere and torr. We can create defined relationship. 1 atmosphere equals 760 torr equals 760 millimeters mercury. What does it mean? 1 torr equals 1 millimeters mercury. It's good to memorize define relationship. Okay, when you focus on units of pressure, you can see atmosphere, torr, millimeters mercury, part per square inch, the bar, and kilopascal. As you know, different relationship, 1 atmosphere equals 76 torr. 1 atmosphere equals 76 millimeter mercury. 1 atmosphere equals 14.7 psi. 1 atmosphere equals 1.01 bar equals 29.9 inches mercury. And then 1 atmosphere equals 101 kilopascal. Okay, pressure over 2.85 atmosphere is equivalent to blank torr. So what is given number unit? 2.85 atmosphere time unit conversion factor on the bottom. 1 atmosphere equals 760 torr. So you can get 2166 torr. So you can see significant figures. There are 3 significant figures here, exact numbers. So we need 3 significant figures. So 170 torr. So what's final answer? Number 4. So temperature of the gas sample. So calculation use Kelvin temperature scale. So absolute zero is temperature of the 0 Kelvin and particle have no kinetic energy because all motion stops. On the Celsius scale, absolute zero is equal to minus 273 degrees Celsius. So we can convert degree Celsius to Kelvin, degree Celsius to Kelvin, or Kelvin to degree Celsius. Okay, so we can use define relationship. Kelvin equals degree Celsius plus 273. What is given? That is 37 degrees Celsius. Insert this number into equation. Finally, you can get 310 Kelvin. When you see given minus 50 degrees Celsius, insert given number in unit. Finally, you can get 233 Kelvin. When you modify this equation to get degree Celsius equals Kelvin minus 273. So when you add given number in unit, finally you can convert Kelvin to degrees Celsius. So 127 degrees Celsius. When you see simple gas law, for example, Boyle's law describe pressure and volume behavior of a gas sample is maintained at constant temperature. So Boyle's law equation P1 V1 equals P2 V2. So P is pressure, V is volume, number 1 is initial, initial. Number 2 is final. So, Boyle's law equation is initial pressure time, initial volume equals final pressure time, final volume. Second simple gas law is Charles law. Charles law describes temperature volume behavior of gas. Samples kept at constant pressure. So Charles law equation is initial volume over initial temperature equals final volume over final temperature. You have to use Kelvin unit for temperature. Kelvin unit for temperature. The third gas law is combined gas law. Combined gas law describes pressure, volume, and temperature behavior of a gas sample. So equation is initial pressure times initial volume over initial temperature equals final pressure time, final volume over final temperature. You have to use typical unit Kelvin for temperature. Okay, let's solve problems. A gas sample has a volume of 2.50 liters. When it is at a temperature of 30.0 degrees Celsius and pressure of 1.80 atmosphere, what volume in liters will all the sample have if pressure is increased to 3.00 atmosphere, temperature is increased to 100 degrees Celsius? So when you modify combined gas law equation, so final volume equals initial pressure time, initial volume time, final temperature over initial temperature time, final pressure. As you know, we need to convert degrees Celsius to Kelvin. So 100 degrees Celsius plus 273 equal 373 Kelvin. So insert given number unit. Finally, you can calculate final volume, 1.85 liters. So Avogadro's gas law equation is initial volume over initial amount of gas equals final volume over the final amount of gas. And also you need to memorize standard temperature and pressure. We can call STP. STP condition 0 degrees Celsius and 1.00 atmosphere. 1 mole of any gas molecule has a volume of 22.4 liters at STP. So STP condition 0 degrees Celsius, 1.00 atmosphere, 1 mole, 22.4 liters. Okay, so memorize STP conditions. 0 degrees Celsius, 1 atmosphere, 1 mole, 22.4 liters. So ideal gas law equations. Ideal gas law gas law equation is pressure times volume equals number of mole of gas times ideal gas constant 0.0821 liter atmosphere over mole Kelvin time Kelvin temperature. Okay. 2.50 mole sample of gas is confined in a 6.17 liter tank at a temperature of 28.0 degrees Celsius. what is pressure of the gas in atmosphere? So use ideal gas equation. Okay, so pressure equals mole of gas times ideal gas constant time Kelvin temperature over the volume. Okay, so you need to convert degrees Celsius to Kelvin first. You can get 301 Kelvin and insert given number in unit. Finally, you can determine pressure, that's 10.0 atmosphere. Okay, use ideal gas law to calculate volume of 0.413 mole of hydrogen gas at a temperature of 20 degrees Celsius and pressure of the 1.20 10 to the third torr. So first convert degrees Celsius to Kelvin and then torr to atmosphere. Then insert given number in unit. Finally, you can calculate volume 6.29 liters. So if mass is known, number of mole in the sample equals the mass in grams divided by molecular weight. So number of mole equals mass divided by molecular weight. Substituting this in either gas equation gives pressure time volume equals mass time either gas constant time temperature over molar mass. Okay, 4.00 gram of sample of gas is found to exert the pressure of 1.71 atmosphere when confined in a 3.60 liters container at a temperature of the 27 degrees Celsius. What is molecular weight of the gas in grams per mole? So first, we need to calculate more moles from the gas equation. So mole equals pressure time liter over gas constant time temperature. So we can get 0.250 mole. From the given equation, insert given number in unit mass and then we calculated number of mole. Finally, you can get molecular weight 16.0 gram per mole. So total pressure exerted by mixture of the gases is equal to sum of partial pressure of gases in the mixture. So you can determine total pressure equals partial pressure of components. So for example, what is the partial pressure of argon? If total pressure of the gas mixture is 5.8 atmosphere, the pressure of the other gases are 2.7 atmosphere. So total pressure is 5.8 atmosphere equals partial pressure of argon plus partial pressure of other gases 2.7 atmosphere. Finally, you can get partial pressure of argon equals 5.8 atmosphere minus 2.7 atmosphere. So finally, you can get 3.1 atmosphere. That's partial pressure of argon, number 2. Graham's law laid of the efficient or diffusion of two gases. Two masses of the molecule of the two gases. For example, efficient rate of the A over efficient rate of the B equals root molecular mass of the B over molecular mass of A. So You need to know definition of efficient and deficient. Efficient is process in which a gas escape from a container through small hole in the container. Diffusion is a process causes the gases to spontaneously mix when they are brought together. Okay, let's compare later the efficient or deficient for neon and krypton gases. Molar mass of the neon and krypton are 20.18 atom mass unit and 83.80 atom mass unit, respectively. Let's use equation. Rate of the neon over rate of the krypton equals root molar mass of the krypton over molar mass of the neon. So we can get 2.038. What does it mean? Neon gas diffuse or diffuse about twice as fast as krypton gas. Changes in state. Changes in state caused by adding heat to substance are classified as endothermic process. Changes state caused by removing heat are classified as exothermic processes. In endothermic process, you can see sublimation, solid to gas, that's sublimation, liquid to gas, that's evaporation, okay, solid to liquid, that's melting. In exothermic process, you can see deposition, gas to solid, that's deposition, gas to liquid, that's condensation, liquid to solid, that's freezing. Which of the following phase changes endothermic? What about condensation? That's exothermic. Deposition, exothermic. Evaporation, that's endothermic. Freezing, exothermic. It is good to know definition of the evaporation. Evaporation is a process in which a liquid is changed to a gas. Condensation is process. A gas or vapor is changed to liquid. Sublimation is endothermic process. A solid is changed directly to gas without first becoming a liquid. The melting is broken down of the rigid ordinarily solid structure into mobile disorderly liquid state. Dry ice is solid carbon dioxide. Its name implies it undergo which of the following phase change? That's sublimation. Okay, solid state to gas state. That's sublimation. Okay, specific heat. Amount of heat energy required to raise temperature of exactly 1 gram of substance by exactly 1 degree Celsius. So you can calculate heat. Heat equals mass time, specific heat time, temperature change. Temperature change, we can get finite temperature minus initial temperature. So you can refer to specific for selected substance. So aluminum, calorie per gram degree 0.24, joule per gram degree, that's 1.0. Okay, also you can check specific heat of copper, ethylene glycol, lead, mercury, oxygen, water. Okay, thank you for watching the video.